Sa ating mga nakaraang video, napag-aralan natin ang pagmultiply ng polynomial using conventional method o yung tinatawag na traditional multiplication. Multiplying that kind of method or applying this kind of method is a tedious work or time-consuming. So in today's video, pag-aaralan natin ang pagmultiply ng polynomial using short method which is known as special product in order to save time. But what is special product? Special product, ito yung special form of algebraic expressions whose product are immediately apparent or can readily seen. We do not need the solution anymore when we find the product, such as this. We will write the answer directly. Kung kaya we are going to study or look for a pattern to lessen our work or that will make our work easier. So I will show you how this works. But in the meantime, we shall develop some special rules so that product can be obtained in less time and less work. We shall discuss the following topic or the types of special product. So I have enumerated here the 7 types of special product. Let's start with, or let us begin with, square of monomial. So the second one is the product of sum and difference of two binomials. The third one is the square of binomials. The fourth one is the square of trinomial. Next is the square of quadrinomial. And the sixth is the cube of binomial. And the last we have is the product of a binomial and trinomial in the form of this formula. Summarizing the types of special product, we have the squaring of monomial, product of sum and difference of two binomials, square of a binomials, square of a trinomials, square of quadrinomials. Number 6 is a cube of binomial, and the last we have is the product of binomial and trinomial in the form of this formula. Let us have some example to illustrate the application of the different types of special products. Let's start with square of monomial. So we have here the different steps. So first, we will multiply the numerical coefficient by itself. Second one, we will double the exponent of each letter. So let's start with problem number 1. 4x raised to 5 raised to square. So how do we simplify this monomial? So what we will do is to multiply the numerical coefficient by itself. So 4 by 4, so that is understood to be 16. Double the exponent of each letter or variable. So the variable is x, so we write x here, and we will double the exponent of the variable, or simply multiply 5 by 2, so that is understood to be 10. So 4x raised to 5 raised to square is equal to 16x raised to 10. Number 2, we have the quantity of negative 3m7 n raised to 4 raised to square. So what we will do is to multiply the numerical coefficient negative 3 by itself. So we have negative 3 by negative 3, so that is understood to be positive 9. And then retain the variable m and n here. So we have m and n, and then we will double the exponent of each variable or letter. Or that is the same as multiplying it by 2. 7 times 2, so the exponent of m is 14. 4 times 2, so the exponent of n is simply 8. So when we square negative 3m7 n raised to 4, the answer would be 9m raised to 14 n raised to 8. Number 3, so we have the quantity of 7a6 b raised to 9 c raised to 8 raised to square. So again, we will multiply the numerical coefficient by itself. So 7 times 7, so that is equal to 49. And then retain the variable a, b, c here. So we have a, b, c. And then double the exponent of each variable, or just simply multiply that by 2. So 6 by 2, so that is 12. So that is exponent of a. 9 by 2, so that is 18, so that is exponent of b. And the last we have 8 by 2, so that is 16, so that is the exponent of c. So when you square 7a6 b raised to 9 c raised to 8 square, the answer would be 49 a raised to 12 b raised to 18 c raised to 16. So last number we have 3 all over 5 x raised to square y raised to 10, and then that is being raised to square. Again, we will multiply the numerical coefficient 3 all over 5 by itself. So 3 times 3, so that is 9. 5 by 5, so that is 25. So the numerical coefficient is 9 all over 25. And then retain the variable x, y. So we have x here and y. Then multiply the exponent. So 2 times 2, so that is the exponent of x, which is 4. 10 times 2, so that is the exponent of y, which is 20. The next type is simply the product of the sum and the difference of the two binomial. When we say the product of binomial, sum and difference, that is simply equal to the square of the first term minus the square of the second term. It can also be known as the product of sum and difference of the same two terms. So how do we get the answer here? Just simply multiply the first term and that becomes a square. Multiply the second term and that becomes b squared. So positive multiplied by negative, so the sign between the given two term or the answer is simply negative. So let us have an example. A plus b multiplied by a minus b. So this is the first term. So we will multiply the first term to get the first term with answer. So we have a square and then 5 by negative 5, so that is negative 25. So we have the negative here. Next problem we have is 9 plus x multiplied by 9 minus x, that is simply equal to 9 times 9, so that is 81, and then x times x, so that is x squared, and then place a minus sign between the terms. That is very much the same as when you multiply positive by negative, so that is negative. Just remember that the answer when it comes to the product of the sum and difference of the same two terms contain only two terms in the answer. So for number 3, so we have 2x minus 7y multiplied by 2x plus 7y. So multiply the first term, so 2x by 2x, so that is equal to 4x squared. Then 7y by 7y, so that is 49y squared. Place a minus sign between the terms, so we have the negative sign, and that is the same as negative times positive, that is negative. So number 4 we have xa multiplied by xa, so that is equal to x squared say square, and then my times my, so that is equal to m squared y squared, and place a minus sign between the terms. That is the same as negative times positive, so that is negative. And the last problem we have is 4 all over 5 multiplied by 4 all over 5, so understood to be 16 all over 25. And the variable should be a squared b 4. So the first term of the answer would be 16 all over 25 a squared b 4. So we have the second term of the answer. So we have 6 by 6, so that is equal to 36. C cubed times C cubed, so that is C raised to 6. And place a minus sign between the terms. So these are the example when it comes to finding the product of the sum and difference of the same two terms or the two binomials. The next type is simply known as the square of binomial. So when finding the square of binomial, that is simply the sum of the square of the first term twice the product of the two terms and the square of the last term. So when squaring binomial, the product composed of three terms. To obtain the first term here, just simply square the first term, so that becomes a square. To get the last term, simply square the first term of the given, so that is b by b, so that is b squared. And the middle term should be twice the product of the first and the second term, which is 2ab. Now, if the sign between the first and two term is positive, all the terms must carry a positive sign. Now, if the sign between the given two terms is negative, the middle term will carry a negative sign. So let's have an example. The quantity of a minus 7 raised to square. So we will square the first term to get the first term of the answer. So we have a by a, so that is a squared. Then 7 by 7 for the last term, so that is positive 49. And the middle term should be twice the product of the first and the second term. Double their product. So we will multiply the first and the second term and then times 2. Double the product. So 7 times a, 7a times 2, so that is 14a. And then whatever be the sign between the first and the second term, that would carry the sign of the middle term, which is negative. Okay, for number 2, so the quantity of 3m plus 2n raised to square. So to obtain the first term of the answer, we will square the first term. So we have 3m by 3m, so that is equal to 9m squared. To obtain the last term, so we have 2n by 2n, so that becomes 4n squared. Now to get the middle term, we will multiply the first and the second term, then we will double it, or we will multiply it by 2. So 3m times 2n, that is 6mn times 2, so that is 12mn. And then the sign will always be positive if the sign of the first two term is positive. For number 3, we have the quantity of 6 minus 5p raised to square. Now to obtain the first term, square the first term, which is 6. 6 by 6, so that is 36. 5p times 5p to get the last term, so that is positive 25p squared. Then to get the middle term, we will multiply the first and the second term, then always multiply it by 2. So 6 times 5p, so that is 30p times 2, so that is 60p. And then the sign of the middle term should be the sign of the sign between the first and the second term, so that is negative. For number 4, we have the quantity of 2x squared minus 8y cubed raised to square. Now to obtain the first term here, square the first term. 2x squared times 2x squared, so that is 4x4. To obtain the last term here, we need to square the second term. 8 times 8, so that is 64y6. And to get the middle term, we will multiply the first term and then we will double it, or times 2. So 2 times 8, so that is 16 times 2, 32. And then multiply the variable x squared y cubed. So that is 32 x squared y cubed. And then whatever be the sign between the given two terms, that would carry the sign of the middle term, is also negative. And for the last problem, we have 2 all over 7b squared plus 3c d4 raised to square. Now to obtain the first term here, we will square the first term. So we have 2 times 2, that is 4. 7 times 7, so that is 49. So that becomes 4 all over 49 b4. So that would be the first term. Now to obtain the last term, square 3 here, so that becomes positive 9. Then c square, then 4 times 2, so that is d raised to 8. And then for the middle term, we will multiply the first and the second term, then times 2. So we have 2 times 3, 6 all over 7 times 2, so that is 12 all over 7 b squared c d4. And then copy the sign here, which is positive. Now another example, let's say, what about if you are given with quadrinomial in form, meaning to say the given is not in binomial, that is quadrinomial, that is being raised to square. So how do we solve it? We cannot exactly use this formula, square of binomial, but we can transform this quadrinomial expression into a binomial square using grouping, I should say. So what we will do now is we are going to regroup the first and the second term to be treated as first term, and the third and the last term to be treated as the second term. So that becomes square of binomial. If that would be binomial, then therefore we can now apply this formula. Okay, let's do it. So we will enclose the first and the second term to be treated as one term, and then the third and the last term to be treated as the second term, and that is being raised to square. So this time 3m minus 2n, that is your first term. That is also treated as a. So let us indicate here as a. Then 5p minus q, that is simply our b term. So we will indicate this as b. Then applying this formula, so what will happen then? So we will square a. A happens to be 3m minus 2n. So we will square 3m minus 2n raised to square to get the first term. To get the last term, we need to square the b. Happens to be 5p minus q. So we have the last term here, which is 5p minus q raised to square. And then the last term, that should be the product of the first and the second term, then times 2. So we have the first here, which is twice the product of 3m minus 2n multiplied by 5p minus q. And what would be the sign? Since the sign is positive here, the sign of the middle term should carry also a positive sign. Now, next step here is we need to simplify. Now, if you observe, the quantity 3m minus 2n raised to square and 5p minus q raised to square happens to be in the form of square of binomial. So we need to square this first term and the last term. So let's do it. So 3m by 3m, so that is 9m square. And then negative 2n by negative 2n, so that is positive 4n square. Now to obtain the last term, we will multiply 3m by 2n and times 2. So we have 3m times 2n, that is 6mn times 2, so that is 12mn. Then copy the negative sign here for the middle term. Now for the middle term here, which is 2 multiplied by 3m minus 2 and 5p minus q, we need to simplify this. So let us try to multiply the monomial by this binomial, and then we are going to retain 5p minus q. So 2 times 3m, so that is 6m. 2 times negative 2n, that is negative 4n. And then retain 5p minus q. These are going to multiply by 6m minus 4n. And then the last term appears as the square of binomial. So we need to square 5p, and it happens to be 25 p square. And q times q, so that is positive q square. And then to obtain the middle term here, we will multiply 5p by q, that becomes 5pq times 2, so that is negative 10pq. So we have the negative here. Then retain the first three term here. So we have 9 square minus 12mn plus 4n square. And we are going to multiply these two binomial using FOIL method or the long one. So 6m by 5p, that is equal to positive 30mp. 6m by negative q, so that becomes negative 6mq. Negative 4n by 5p, so that is negative 20np. Negative 4n times negative q, so that is positive 4nq. And then retain the 25p square minus 10pq plus q square. So this is the final answer when it comes to finding the product of this square of quadrinomial. But we can also rearrange the final answer as 9m square plus 4n square plus 25p square plus q square minus 12mn plus 30mp minus 6mq minus 20np plus 4nq, and the last term we have the negative 10pq. So that is the final answer.